Okay. Uh, can you able to get my screen?
Yes, sir.
Okay, fine. So this is the Xilinx IC project navigator that uh, we are using to execute different VHDL codes. Okay. So now in today's lecture, I will demonstrate you with one or two example how to use this IC simulator, Xilinx IC simulator, and how to execute VHDL programs in it. Okay. So I hope all of you are able to get my screen. So first, when you click on this Xilinx IC simulator, this window will appear in front of you. Okay. Now, what we can say, this is the home window. This is the home window for this. Now, in that case, now, first, as we are doing anything while you are performing different C programs, or while you are performing different MATLAB programs, what you are doing first, you have to create a new project, right? You have to create a new project. So similarly, here also, we are going to create first new project. So click on this file, then new project. When you click the new project, this window will appear in front of you, right? This window will appear in front of you. Now here you have to give name to your project. So first we will go for the full adder VHDL program. Okay, then we will write here full adder. Okay, so this is the name I have given. Then click on the next button. Okay, then it will ask should I create this full adder folder, so that every program related to this design will get stored into that particular file. So you have to simply say yes. Okay, after saying yes, this window will get appear in front of you. So as we are not bother about the actual implementation, when you have to implement that program on particular target board. For example, you can see here this Spartan family, this Spartan FPGA, but we are not going to actually what we can say debug on a particular target board. So we simply omit this part, then click on the next button. Okay, then finish. Okay, now after finishing, this kind of window will get appeared in front of you. Okay, then as we have created this folder, now again click on this, and here click on a new source, right? Click on a new source window. Now this kind of window will appear in front of you after clicking the new source. See, again I will repeat. First, what we have did, we have created a project, right? We have given project name as a full adder is our project. Then now in this project, we are now creating a new source. That means now actually we are adding our VHDL or .vhdl file into this particular project. Now again you have to give name to your project full adder. So here I will give different name. So I will give uh, FADD, FADD, that is full adder, or I will give full add, FULL add. You can give any name. You can give your own name also, no problem. Now here I have given name as a full add. Okay, location, it is by default the Xilinx simulator, as we have created this folder. In that same folder, our all this VHDL program will get stored. So location is by default it is selected. So you need not to bother of this. Okay, then what code we are writing here? A VHDL code. So here you have to select a VHDL module. You have to select a VHDL module. Then click on the next button. Now this kind of window will appear in front of you, and it is now entity name is full add that I have given. Then architecture name is behavioral. Okay, in this architecture behavioral you are using, you can change here with data flow or structural, whatever you want to use. Okay, now here this is the entity window. Now here actually we have to finalize what are the inputs and output ports that we require for a full adder. Now tell me, what are the inputs and output ports that we require in case of full adder? How many inputs we require in case of full adder?
3.
Hmm? Three inputs, right? Which are those? A,
B and
B
C.
and C.
B, and C in. Okay. Direction you can see here. I have kept it as a in. You can change it direction also, in out, and out. Okay. So, but we require in, so I have kept it as a in only. Okay. Now, if you want to make it as a single bit or can be of double bit or more than one bit. If you want to use this full adder more than one bit, then you have to click the bus here and you have to simply mention the MSB value and LSB value. Means actually we are doing that 3 down to 0, right? Or 4 down to 0. So likewise you can do here. So if 3 down to 0, then you have to mention here 3 and mention here simply 0, so it will be 3 down to 0. If you want to give the 4 down to 0, now you can give here the 4 and you can mention here the 3. So that is all you want to do that here. So it is 3 down to 0, but as we not require a bus, so we will not mention anything here. Okay. Okay, now how many inputs we require? Two inputs, sum and carry. Sum and the carry. Now these are the outputs. So we have to change as a out. We have to change this as a output mode. Okay. Now I have defined the inputs A, B, and C in, and I have defined the outputs sum and carry. Okay. Now I will click on to the next button. Okay. So here it will show me the summary of what we have written. So A, B, C pin we have 5 pins we have selected, and A, B, C is of mode input and sum and carry is of mode output. So this is the summary that we will get. Okay. Then click on the finish button. After clicking on the finish button, now this window will appear in front of you. Now, what this VHDL have done here, so this library part, it is by default included in this code. This library part, you can able to see here, library IEEE, and in that library, standard logic 1164.all, this is package that it is already there. Now, entity also, as we have selected the input output port, this entity part also you will get ready-made. You need not to write that entity part also, right? This entity part is already there. A, input standard logic, B, input standard logic, C, input standard logic, sum and carry. Okay, and full add. So this is the entity name that we have decided. So same will appear here. Then architecture behavioral of full add is. Now after begin here in this, you have to write the actual program. Okay. Now we have normally use the data flow style, right? We are using the data flow style of modeling. So what we should return in a data flow, a direct Boolean equations, right? That we will get from the Carnot map reduction. Whatever the Boolean equation that we will get for the sum and carry in case of full adder, that we have to write here. Now, first I will write the equation for sum. So this is sum will get value. Now tell me what is the sum equation for full adder?
A XOR with B XOR with C.
Yes. So you have to write here A XOR B XOR C in, ended by semicolon. Sorry, here B I should write. Okay. So B. Fine. Clear? Yes or no?
Yes, sir.
Am I right? Yes. So what will be the carry equation? Carry will get, okay. What will be the carry equation?
AB plus BC plus XC.
Yes. So first A and B, okay, or in next bracket B and C in, right, or, and in the last bracket A and C in, for ended with semicolon. Am I right? I have written the expression correctly. A XOR B XOR C in. Next, A and B or B and C in or A and C in. Clear with this? बरोबर आहे का? Sum आणि carries equation. Okay. Now here already it is and behavioral style is already there. Okay. Now we have written this program, okay, for full adder. Now we have to save this. So you have to click on the save button. See, every change you made on your program, you have to click onto the save button. You have to click onto the save button. Okay. So this is our program now. Now you have to go. Now we have to check the or we have to synthesis this program to check the error. If there is any error or it is correct. So you have to select this file. So this is our VHDL program or VHDL module. Then here you can see different processes. You can see here design summary report, then design utilities, user constraint, then synthesis, implement design. So we want to just synthesis. See, in case of VHDL, compiling is nothing but synthesis. Compiling is nothing but synthesis. So we have to click this synthesis. Then you can find these many options: view RTL schematic, view view technology schematic, and check syntax. So click on this, double click on this check syntax button, right? And now you can see here a green circle with the correct arrow will appear in front of you. That indicates whatever the program that we have written, it is good or it is errorless. It is errorless. That is correct one. Okay. Now again, you can go for this RTL schematic also. If you double click on this, you can able to get the RTL schematic of this. That means now see, this is the what we have designed. This is the A, B, C in inputs, sum and carry is the outputs. Now again, if you want to go into a detail, right, we have discussed we can go up to a 3 levels of what we can say 3 levels of details in case of VHDL. So again, if you want to get inside this, so you have to double click this block. Now here you can able to see a inside circuitry present within this full adder block. Okay, this inside circuitry you can able to see within this full adder pack. So these are the AND gates, 3 AND gates you have. Then 3 AND gates is connected to this multiplexer, and finally you are getting the sum equation. And from this carry, this carry is again added with this multiplexer, sorry, this XOR gate, and you are getting the carry from this, and this multiplexer will give you the sum. That means this is the inside circuitry. This is the inside circuitry. Clear? So in this way you can get different RTL schematic as well as the circuit which is used to. Okay, now you can able to see. Now this is the total circuitry. Okay, this is the A, C in A and B. These 3 AND gates we will require, this XOR gate, and this is the multiplexer. Now in this black box, right, in this black box, as we have written the program, so now that VHDL code get converted to the equivalent circuit, right? That 2 lines that we have written, आपण ज्या 2 लाईन लिहिल्यात का नाही, सम आणि कॅरीचं इक्वेशन. So this VHDL, this HDL tool has converted that what we can say VHDL code into its equivalent digital circuit. बरोबर आहे. आता तुमच्या लक्षात आलं का आपल्याला VHDL चा यूज, नाहीतर आपल्याला काय करावं लागलं असतं, हे सर्किट आपल्याला बिल्ड करत बसावं लागलं असतं, होय की नाही. इफ यू वॉन्ट टू get a proper result, or if you want to design full adder manually, then you supposed to design this circuit. But now you are getting this circuit with just 2 line code. बरोबर आहे का नाही. आपण फक्त काय लिहिलं, समचं इक्वेशन लिहिलं, कॅरीचं इक्वेशन लिहिलं, and now we are getting this internal circuitry after synthesis. Now your design is ready. Now hereafter, now you have to simulate this circuitry. बरोबर आहे का नाही. आपण डिझाईन तयार केलंय, पण ते डिझाईन वर्क होते का नाही प्रॉपरली, किंवा एक्सपेक्टेड आउटपुट आपल्याला मिळते का नाही, ते कसं चेक करणार. फॉर दॅट पर्पज वी हॅव टू गो फॉर द देन सिम्युलेशन पर्पज, राईट. that's why we have to go for the now simulation of this circuit. म्हणजे आता आपल्याला याचं सिम्युलेशन करायचंय व्हाया टेस्ट बेंच सर्किट, व्हाया टेस्ट बेंच कोड. टेस्ट बेंच म्हणजे काय, ॲज द नेम इंडिकेट्स, इट्स द कोड टू टेस्ट दिस सर्किट. हे सर्किट जे आपण डिझाईन केलेलं आहे ते आपल्याला टेस्ट पण केलं पाहिजे. बरोबर आहे की नाही, की प्री डिफाईन्ड इनपुट देऊन आपल्याला काय आउटपुट मिळतं हे चेक पण केलं पाहिजे का नाही. ते डिझाईन किंवा हे सर्किट जे आपण बनवलंय ते आपल्याला चेक पण केलं पाहिजे. त्यासाठी आपल्याला आता ह्याचा टेस्ट बेंच कोड लिहायचा, म्हणजे काइंड ऑफ आपल्याला ते सर्किट आता टेस्ट करायचंय, चेक करायचंय. ते कसं करणार ते आता आपण पाहूया. ऑल ऑफ यू हॅव क्लिअर विथ दिस. दिस इज युअर इंटरनल सर्किट अँड दिस इज युअर कोड. म्हणजे हा जो आपण कोड लिहिलेला आहे त्याचं हे इक्विव्हॅलंट सर्किट आहे, त्याचं हे इक्विव्हॅलंट सर्किट आहे. क्लिअर विथ दिस, समजलंय का. समजलं आहे का.
Yes, sir.
Fine. Now we have checked the syntax, right. We have seen the RTL schematic of this. बरोबर आहे. हे RTL schematic कसं काढायचं कळलं ना. Again I will explain. You have to double click on this view RTL schematic. Okay, then this block you will get, and if you click if you double click inside this block, you will get this circuit. Right. So this is the RTL schematic. Clear with this. Okay, see, the rest of the options are required if you want to actually debug this code onto particular target board. म्हणजे जर काही डिझाईन तुम्हाला एखाद्या CPLD किंवा FPGA वर डिबग करायचं आहे तर हे बाकीचे ऑप्शन्स तुम्हाला लागतात. बट हिअर वी आर नॉट गोइंग फॉर दॅट. वी आर सिम्पली सिम्युलेटिंग दॅट with the help of test bench. Okay, now you can able to see here, now we are at the implementation mode. Here you can see the cursor that I am moving from. Okay, now we have to we are at the implementation mode. Now we have to shift to the simulation mode. Okay, now first we will shift to the simulation mode. Okay, now after shifting to the simulation mode, again you have to select our code, right? You have to select our code, then again right click, then new source, right click, then new source. Now here again we have to name. Now as we are testing our circuit, so what I will give the name, full add TB, that is test bench, full add TB. Now we have to go for this VHDL test bench. म्हणजे पहिले आपण काय सिलेक्ट केलं होतं, VHDL मॉड्यूल. आता काय सिलेक्ट करायचं, VHDL टेस्ट बेंच. का, आता आपल्याला सिम्युलेट करायचंय, टेस्ट करायचंय ते सर्किट. दॅट्स वाय आय हॅव सिलेक्टेड द VHDL test bench. Then next, okay, next, finish. Now this is the test bench code for the same. बघा आता खाली इथे आपल्याकडे 3 आहे. दिस इज अवर ओरिजिनल कोड, दिस इज द VHDL कोड, दिस इज द RTL equivalent design that we also have, and this is the test bench code. Now in this we supposed to test our circuit. Okay, okay. Now here we have to write the different test cases. बरोबर आहे. आता टेस्ट केसेस आपल्याला कशा चेक करायच्या आहेत, आपण काय टेस्ट केसेस लिहिणार. फॉर एक्झाम्पल प्री डिफाईन्ड आपल्याला टेस्ट केस, म्हणजे फॉर एक्झाम्पल तुम्ही एक कुठलाही बीट सांगा. व्हॉट शुड आय विल टेक फॉर ए, okay, then what should I take for B, and what should I take for C in. Okay, now tell me, A काय घेऊ दे मी, 0 or 1, as we have selected only one bit, so you have to tell me either a 0 or 1. What the A value should I take? Okay, I will take it as a 1. Okay, what B value? B value काय घेऊ दे, 0 का 1?
0.
0. Okay, and what should I take a C in? Okay, again I will consider that 0. C in is also 0. Now I have taken A as a 1, B as a 0, and C in as a 0. Okay, now what sum I will get, बरोबर आहे. सम इज इक्वल टू व्हॉट, A XOR B XOR C in. बरोबर आहे. मला सम प्रोबॅबली काय मिळालं पाहिजे, 1 XOR 0 XOR 0. what should I get the sum value as a
1.
1. व्हेरी राईट. म्हणजे हे यू नीड टू कॅल्क्युलेट दिस. सम आपल्याला 1 मिळाली पाहिजे. अँड व्हॉट कॅरी शुड आय गेट, कॅरी पण कॅल्क्युलेट करून सांगा मला लवकर.
0.
carries 1 and b. So
0.
1 into 0, that is 0. Second one is also 0, and third one is also 0. Then 0 or with 0 or with 0. So it's a 0 and sum is equal to 1. म्हणजे मला सम 1 मिळाली पाहिजे आणि कॅरी किती मिळाली पाहिजे? 0. Right? Now and in this way, see, after this delay again you can write here new test code also. हे आपण टेस्ट कोड लिहिलेले बरोबर आहे. इथं तुम्ही असे किती केसेस लिहू शकता. In second place you take as a as a 1, b as a 1, and c in as also 0 or 1, anything, and you have to check the or you have to verify the design with the help of test bench. Okay, so for your understanding we will consider here just one test case only. Okay, now a we have taken 1, b we have chosen its value as a 0, and c we have chosen its value as a 0. So expected outputs are sum is equal to 1 and carry is equal to 0. Okay, now we will check whether we are getting this or not. Okay, now again you have to select this part, and in this, okay, just you have to ensure one thing: the view mode that you should select as a simulation mode. Okay, if you are in implementation mode only, you will not be able to get the output. So necessarily you have to select this simulation mode only. Okay, now we have selected this, then click on this IIC simulator and again click on this behavioral syntax check. Means again you have to check the syntax with this. Okay, now this corrected arrow appears with green sign that indicates whatever code that we have written is correct. Okay, now second option you can say simulate behavioral model. You can see here simulate behavioral model. You have to double click on this and you will get now the window where you can get the output. Yes, okay, you can get the output. Now see, you can see here this below level is 0 and this above level is 1. So what output we were expecting? Sum should be 1, carry should be 0. We got the corrected output. Sum you can see as a 1 and carry you can see here. Sum we are getting as a 1 and carry we are getting as a 0. That means whatever the program we have written, that is correct, that is faultless, that is flawless. Sum we got the 1 and carry we got the 0. This is the simulation. This signals will tell you the value, right? Signal which is at the upside indicates the logic 1, signal which is at the bottom side which indicates the logic 0. So you can see this carry signal is at bottom side, that means it is at logic 0, and this a and some signal you can see at some upper side, that means at logic 1. So in this way you can simulate any VHDL code, and you can check its syntax as well as you can simulate this with the help of this test bench code. That means you can verify that design also with the help of this test bench code. Clear with this? समजलं का सगळ्यांना?
Yes, sir.
Okay. Now you tell me what other code should I write here? Now you just tell me. Okay, I will close this part. Again I will go back to a implementation. Okay, so this is what we have designed, no problem. Okay, now tell me what next code we should go for. Comparator, 1-bit comparator. Is it okay?
Okay, sir.
Okay, now you have to tell me the process. Okay, I will do here only. Any one of you. Okay, So this is the window that we have. Now we have to go for another code. So what we should do first now, we have to create a project. Okay. Now where should I click then? Can anyone fast? You have to tell me so that we will able to complete the code. Okay, we have to click for again file, then again new project. Okay, now I will name comparator. Okay, then next finish. Okay, now this is comparator we have arrived at. Now next what we have to go, what we have to do here, we have to click on this folder, right click on this and add new source. That means now we have to add a new source. Now select the VHDL module and you have to now name the entity. काय नाव देऊ दे? comp, right? I will give name as a comp. Okay, next. Okay, now entity name is comp, that is comp. Now we have to decide how many inputs and outputs we require. Okay, now tell me how many inputs we require. We are considering here a 1-bit comparator. You can go for 2-bit comparator also, no problem. Please come up fast. A and B. These 2 bits we will require to compare. And output, you can choose anything. So here normally we will choose as a GR for greater, then LS for less, and EQ for equal. Okay, and these are the output pins that we will require. So here I have set them as a output. Okay, then next, so here we will get summary. A, we will require, in all we will require, we will be requiring 5 pins. So A is of mode input, B also is of mode input, and greater, LS, and equal to, GR for greater, LS for less, and EQ for equal sign. So that we will use for outputs. Okay, now and finish. And here is the here we got the program window. Okay, now here you can able to see it's 11:13 and that is 6 July 2020. Everything you can see here. Okay, so these are the libraries which I have already included. This is the entity part which is already there. Now here after begin we have to write the actual code. Okay, now tell me the logic, how to how we should implement this. We have to use the process statement here, right? Process in bracket A comma B. After process begin, enter. Okay, now tell me process A comma B begin. Now if first case, what we will take, A is greater than B. A is greater than B. Then what we should get here? GR should get value 1. Else GR should get value 0. Now and if. Okay. This is and if loop. Okay. Now next loop again. If. Now we will consider the second example. If A is less than B. A is less than B. Then what we should write here? LS should get value 1, right? Else LS should get value 0. Okay. And if. Okay. Now what should I write the third case? Again, if. Now the last case. That means A equal to B. Right. Then this EQ should get value 1, else EQ should get value 0. And if. Okay. Now after and if, what should we write? And process and architecture. Okay. Now this is the code for a 1-bit comparator. Okay. Now again you have to select this program, this VHD file, then go for this synthesis, then check its syntax, double click on this. Yes, as I have not saved this file, so it will automatically what we can say, show the pop-up window that whether you want to show the file or not. So you have to select yes there, then check syntax. Oh, it's appeared the correct tick, that means our syntax is right. Then again you can go for this RTL schematic. So this is the RTL schematic. If you double click on that, you will get the internal circuitry. So this is what the internal circuitry for the comparator. A, B, these are the two inputs. Then this GR, LS and equal to, these are the three outputs, and this is what the internal circuit is of comparator. Okay. Now our design is ready. Now what we have to check its functionality. So we have to first shift to the simulation mode, then select this model. After again new source, again give the name. Here I will give the name COMPTB, that is COM test bench. Then select VHDL test bench. Next, finish. Yes. Oh, some error got here. But okay, have you clear about how to execute programs? Have you clear how to execute program?
Yes,
Yes,
Okay, fine. Then we will stop here, and unit number 2 got finished. Okay, so here with your permission, I will declare unit number 2 is also finished. That is VHDL modules for the sequential logic and combinational logic design. कुणाला काही शंका आहे का याच्यात? You can ask. If you have any doubt or query, you can simply ask right now. समजलंय का सगळ्यांना सगळं?
Yes, sir.
Okay, fine. Then we will stop here. From next lecture, we will start with new unit. Okay, probably unit number 3 or unit number 4. That is testing of logic circuits. Okay, so today we will stop here then.